Welcome to the admission talk of the Bachelor of Engineering of our Biomedical Engineering program today. So my name is Kevin Tia. I'm the program director of this program. And before I start today, I know that you are expecting and anticipating a lot, what's going on in this program, what to expect. But before we start, I actually would like to pass the microphone to the Dean of Faculty of Medicine to say a few words. All right, Professor C.S. Lau.
Thank you very much, Kevin. First of all, I apologize for making you wait, I think, a few minutes. Okay, we were supposed to start at 11 o'clock. Today has been a rather tight schedule, and we have many programs, actually, that we need to, disseminate our information to students and parents, etc. This is the first time I'm addressing potential students and their parents, okay, to this biomedical engineering admissions talk. The reason why this is the first time is because the School of Biomedical Engineering was only established in March of this year. This is a very unique school that is typically multidisciplinary, transdisciplinary, and involve multiple faculties, medicine, dentistry, engineering, where Professor Kevin Shah is from, as well as Faculty of Science. So you can tell, actually, we put a lot of efforts and gathering the expertise, okay, from everyone from the 4 different faculties to build this. Well, this has been around for some time to reform and revamp this biomedical engineering program. This is important because whatever that we do in biomedical engineering, the ultimate aim is to help our patients, to make them better with whatever technology, with whatever new developments that we make to help our patients, which is why the university has decided with this multidisciplinary school to have it administered by the Faculty of Medicine. So ultimately, the doctors and the dentists will ask the questions as to how we could help our patients. The scientists and the engineers will then actually design tools and new skills to help our patients, where we can actually try out the new technologies in the medical school and the dental school, etc. So popular this program has become since its sort of a rebirth in March this year, that the last cohort of BME students has exceeded the number that we had from the UGC. We were hoping to recruit 75 students for our September, last month's admissions. But ultimately, students were so enthusiastic, and also they were so good that we have admitted well over 110, right, 111. So this is becoming a very popular program. This is one that is very much part of the whole Faculty of Medicine, as well as our coordinate faculties from dentistry, science, and engineering. And you will find there are a lot of openings, okay, for graduates, both in terms of future career in research, future career in the healthcare system, etc. And you will find, hopefully, through the next 60 minutes or so, the way to get into this program and how you could contribute to the healthcare of not just in Hong Kong, but the world, because Hong Kong University is an international, a global university. And with this, I thank you very much, Kevin. Thanks.
All right, thank you so much again, Professor Lau. Okay, so I think for the following less than an hour or so just try to manage everyone's expectation here. So I myself will give about 30 minutes of introductions of the BME programs. I would actually start from what exactly BME is, and then talk a little bit about what to expect when it comes to studying here in this program in Hong Kong U. And then after 30 minutes or so, actually I invited two of our existing current students, okay, to do some sharings with you, to share their learning experience inside, outside classrooms. And both of them are actually the senior years already, and they have been studying here in this university, in this program for more than 3 years now. So they are, two of the very ideal examples for us to learn more from. Okay, and then I think if we have time, later on we will have a Q&A sessions. If any one of you want to ask anything about the program, about what to expect further, please let me know. Okay, so yes, what I talk about when I talk about BME. So I think Professor Lau just mentioned, first of all, this whole school of BME, it's very new, brand new, just started early this year in March. So again, this is truly a very unique initiatives. Okay, you can't really find anything similar elsewhere in these regions or even over the world. Having 4 faculties join force together, okay, to create the school as well as the programs, that our students can enjoy this truly interdisciplinary education. So we just mentioned about this 110 students, right? Who are they? All right, so this is the hard proof that, pretty much almost the whole class of the year 1 student together with some of our senior students actually having this orientation day early last month. I think all of us had good time, and these are all the students that we just admitted, and I hope they also would enjoy the upcoming few years' time in Hong Kong U. So, and this is also one thing that I would like to point out, that the program itself is actually not new. We have been running this program, operating this program for more than 20 years. Okay, so we actually started this program with the name of medical engineering in 2002, I think even before some of you were born. Okay, and we have been actually running this program for some years. And first of all, this is fully accredited by the HKIE, meaning that if any one of our graduates aspire to be charter engineers in BME area, okay, they can be going along this pathway in the career. And actually starting from 2018, we changed the name to Biomedical Engineering Program. This is also when I actually took over the program directorship. So the whole idea behind is that we try to enrich the curriculum content by having more clinical or biomedical exposures to our BME students, because they have to also learn, okay, to apply all the engineering skill sets and knowledge to real-world clinical settings or real-world biomedical applications. All right, so this is actually where we made the first major revamp in our program. And not until this year, we finally established a new school of BME. So this is, I would say, the next wave of revamp that we are actually doing right now and implementing right now, and trying to even further enrich the learning experience for our BME students, having more interdisciplinary training. So this is actually the sort of the roadmap that we have been going through. And that's why you can actually see that all of these students are actually our alumni right now. So we have been accumulating many generations of BME alumni, and many of them are now actually serving the BME community locally as well as internationally. So talking about the school, the class compositions, I would say that our program is relatively internationalized, with 60% of local students, with the rest of non-local students coming different part of the world. And also we have pretty equal split, okay, between boys and girls. Okay, we have a pretty good gender diversity. Okay, and this is actually the video that we took actually the year before, when we had this what do we call this a super pass party. Yes, okay, super pass party. So this is actually a very traditional party or gathering that we usually have by the end of the semester, right before the final exam. So make sure everyone would enjoy before they work very hard for the exam. So this is actually the occasion that we had all together. Can you actually find where I am? Oh, okay, yeah, right here. So I'm sort of hidden somewhere. Yes, thank you. All right, so what I would like to share with you in the following probably 10 slides or so, I try to sort of point out some of the myths that people have been having regarding what BME is. All right, I try to sort of resolve these myths. Okay, so the number one myth is actually what exactly BME is. Okay, so you have two words here, biomedical and engineering, all right, or three letters, BME. Okay, and maybe I'll just give you some examples, very practical, and this is all the examples that I'm going to show you, they are all built in our Hong Kong U. So first of all, these are actually the projects led by our professors in Hong Kong U, also teaching our BME programs, and some of the projects also involve the participation of our BME students. So one of the projects that you are seeing right here, it's about building a very low cost-effective MRI machine, magnetic resonance imaging. Anyone of you know what MRI machine is? Yeah, I think that if you see TV dramas, movies, or some other YouTube channels, if you have, you would actually see this is actually one of the workhorses in the clinical hospitals or clinical settings where you can do diagnostic in general. Okay, basically to take pictures of your body. Okay, any part of the body, all the way from the brain, from any other internal organs. All right, and if you had a chance to look at these machines, and in fact, by the way, we also have our open labs here on this campus, actually just next building, that we have this MRI machine, not for human, but for small animals. So I would encourage you to go to the lab and take a look and also talk to our students. But in general, these machines are actually very expensive, typically, and they are super bulky. Okay, they are talking about tens of millions of dollars. Okay, putting in the machine, being set up in a hospital, and they are very powerful. They have been being used for many years, and a lot of the disease diagnosis or treatment monitoring basically have to rely on this machine. All right, but one of our professors in this program, okay, they had been trying to think of, okay, so this is just so expensive. It's not going to make it too accessible. So when I say accessible, so we are thinking about whether or not you can even put the whole machine in a classroom, in your office, okay, even at your home, all right? So it has been more like a sci-fi idea around, for many, many years, until very recently, they actually are able to make this happen, all right? And with, of course, I try to avoid too much details here, all right? But it's actually happening right now that we are able to make this very low-cost machine. So of course, I mean, when I say low-cost, it's not something like $10 or $20, okay? But it's much, much cheaper, talking about 1,000 times cheaper than a multi-million or even tens of billion dollars machine, all right? And very importantly, you don't have to put it in a very dedicated renovation or indoor environment. Just in an ordinary office, ordinary classroom, you can still operate this. And this is actually something that one of our professors had developed and invented, and now being tested clinically as well. And many other examples. If you ask me to talk about it, I actually would talk for more than 10 hours, okay, but I'm not trying to do that. But I just want to show you at least two more examples. So this is one particular example is that one of our professors working together with another professor from dentistry, all right? So the whole idea here is that it turns out using diamond, everyone knows what diamond is, right? But these are not the diamonds that you would wear as a ring, okay, or earrings or other parts. But these are actually the diamonds that you can polish them into very fine grains, very small particles, down to very what we call nanoparticles, all right? It's so small that it touches like a toothpaste that you can apply it on your gums or on your teeth, all right? And it turns out, all right, skipping all the details or science behind, all right? So it turns out this very special types of diamond being polished down to a very small scale, it can actually suppress bacterial infection, all right? And this is actually another very good example that how engineering or material science can be combined with dental science or dental clinical applications. And many others, and if you also have time today, and I would also encourage you to go to the lab tours, not on this campus, but on main campus. We also have a few labs being opened to all of you. If you are interested in knowing more about BME, we have 3 labs open for all of you. And one of them is actually talking about how you can make computer chips, okay, flexible. When I say flexible, I mean really bendable. It's so flexible that you can make your computer chips just like a bandage, okay, putting on your skin. Then you can actually detect your sweat, detect your blood, or many other material or different types of substance, okay, on your skin, from which that I can detect what we call the vital signs of any individuals to indicate how healthy or not, okay, for the individuals. So this is just one of many examples. The reason why I talk about this is that what do you think the subject matters that you need to learn in order to build this machine or make this material or build these circuits, okay? Just for example, the first one, all right? In order to really understand MRI machine, first of all, you definitely need to understand the human anatomy, okay? How human being constructed, the whole structures. And then talking about MRI, we are talking about radiation physics, okay? And how does all these combine with the mathematical modeling so that, from this machine I can reconstruct the image, okay? How about the diamond ones? Definitely you need to learn material science. We are talking about bacterial infections, which includes the topics of microbiology, and definitely including chemistry, all right? And here, definitely the electronics, as well as biochemistry too. How you are going to make the electrodes or conducting materials being biocompatible, all right? So this is actually something related to chemistry and combined with electronics. So the reason why I talk about all this idea or all this project is that just to give you some idea, these are all hardcore BME examples, technologies being applied to clinical and healthcare. And in order to really make this happen, you can see that how interdisciplinary in nature the BME is. Okay, in order to really solve this problem, you have to learn multiple disciplines. Okay, and more important is how you integrate this knowledge, and then at the end to solve the problem. So I would say, when you ask me about what BME is, I mean, I myself have many different answers depending upon in what context, but at least I would say this is really some generic answer from me that it's all about how you can create solutions across different disciplines for better healthcare. All right, so this is basically the whole idea of BME. Perhaps, okay, maybe I can give you more example. I think by giving you more example, then you have a better idea, okay, how it actually works. So when I say multidisciplinary or interdisciplinary, what does it actually mean? Okay, I take this as an example, heart disease, all right? Cardiovascular disease actually ranked #1 as the top killer among any other diseases, even including cancers, all right? So one of the major heart diseases, okay, would be this condition called a coronary artery disease, where one of the major arteries get blocked accidentally, okay? And how do you actually do diagnosis, okay, to find out, to detect these abnormal conditions, whether or not the blood vessels or the artery get clogged, okay? And many many technologies out there are available to do diagnostic. I think traditionally, people would use the so-called ECG, electrocardiogram. If any one of you have done any body checks or some other clinical checking, you might have gone through this type of measurement, in which that the clinicians would put multiple lead wires or electrodes onto the body, all right, and then after that they can read out some kind of waveforms. All right, and these waveforms are actually electrical signals. All right, it turns out your hearts are actually generating voltages and current. all right? And these are something that you can read about electric circuits, all right, and from which that you can detect the disease and health condition, all right? And on the other hand, MRI again, so you can visualize, okay, how the heart is actually pumping blood in and out, all right, so in real time, all right? But what I would like to share with you is that there are many other new technologies out there nowadays that you can do this diagnosis even more precise. When I say more precise, is that back to the very root cause here, why do we have this problem? Because the blood vessels get clogged, right? Then can we find solutions that to really go into the blood vessels and just take pictures or even just try to do some kind of measurement so that I would know whether or not this blood vessel will get clogged. Many other methods, including they now can put these very tiny optical fibers into the blood vessels, just like you put the probe, navigates through the fibers, navigates through the vessels, and doing this kind of radar scan, all right? So not only you can see the blood vessel surface wall, but also can look into the deep tissue inside. Just for example here, what you are seeing is basically the cross-sectional view as the probe navigates through the blood vessels. So this patient is a healthy one. So you can see that it's very clean and clear internal regions. But versus these patients, okay, this you can see there's a lot of shadow and graded regions, right? So those are actually the plaque, all right? These are the area, the regions that blocks the blood flow. Okay, so these are actually the device now that you can have this kind of very high definition or high resolutions to visualize what's really going on in your hearts, in that blood vessels, all right? Many others, okay, you can then, based on this information, then the surgeons could basically put the probe, okay, that contains, the material that would be served, first of all, biocompatible. This is what we call a stent, all right, together with this inflatable balloon so that you can enlarge the blood vessels again. During this process, you can let the blood flow going smooth, okay? And of course, if you want to visualize them, you need to have the computer vision knowledge, all right? So that is talking about the mathematical modeling of the image, okay, how you can reconstruct the data. And many examples, due to the limited of time, that I don't have time to really talk too much today, but I just talk about this one, the low-cost MRI machine. And I'm sure that you have been hearing a lot about how AI has been impacting biomedicine. And we have professors in our school, and together I myself also work on some AI research related to medical imaging. So just like here, you can basically send your X-ray scan to the AI model or AI machine, and it will basically tells you what it sees, and then telling you, okay, some of the descriptions, all right, of the abnormality or some irregular shapes or structures in your X-ray scan. And then the clinicians or the doctors would be able to have a better judgment. All right, and this is actually one of my favorite projects, not done by me, but actually done by another professors in our program, is that it turns out biomedical engineering is not only helping to have a better health care, but how about improving health, improving your performance. This is actually an ongoing project together with Hong Kong Sports Institute. So using these flexible electronics, so the professors actually collaborate with the Hong Kong Sports Institute so that they can use this technology to monitor the performance of our Hong Kong athletes. All right, actually this is going to be used to get them prepared for the next Olympics. All right, and so this is actually being used right now and integrated in their training program right now, so that within which that they can closely monitor, all right, their training performance, all right, by measuring different types of vital signs from athletes. Okay, so now back to the curriculum. Okay, what it takes, okay, in order to get to those applications, making impact, right? So back to the very beginning, okay, the students here in BME definitely need to have a very broad-based exposure. When I say broad-based, I mean you have to learn the basic foundation in engineering knowledge, like including computer programming, mathematics, all right, essential knowledge in electrical and mechanical engineering, okay? And on the other hand, you already saw some of the examples already. I'm sure that now you should appreciate the need to learn, understand better biology, okay, all the way from cells or even molecules going all the way up to the entire body. Okay, so you need to understand all these concepts, molecular biology, biochemistries, but more important is that, so these are basically the subject matters that we would let the students learn in their first 2 years. But then after that, in their year 3 and 4, in the center part, this is exactly what they are going to learn and how they are going to integrate all these different pieces of foundation knowledge into different domains of expertise or expert areas in BME, including imaging, bioinformatics, and tissue engineering or regenerative medicines, and so on. Okay, just give you a little peek of our ongoing revamped of the curriculum. So, but in general, I think it's also echoes to what I just mentioned. We basically start from the very foundation level, learning mathematics, engineering, chemistry, and biology. And when it advances to the higher level, we try to introduce more and more specialized areas to the students, all right? And give them more flexibility to choose across different areas. For example, if the students want to learn more about or deep dive into biomedical engineering, okay, you can have a certain pathway, all right? Or you want to learn more about tissue engineering, we also provide certain pathway, okay? So although I didn't talk too much about exactly what pathway is, but we are actually creating all this. One more thing is very, very, very important. I have been emphasizing this in many talks and many occasions when I talk to the students or teachers and parents, is that in our program, we have been emphasizing a lot about having active, practical, hands-on training to the students, all right? So we actually have been having this kind of vertical integration all the way from year 1 to year 4, how they can practice their hands-on learning mindsets, first of all, by shadowing the lab, and then gets their hands dirty to actually work on something, build some devices, and then getting into industry to do internships or research labs to do research assistants. All right, at the end, they can have their own projects as a final year assessment. All right, so these are basically the progressions that we are providing to the student so that they have progressively learned knowledge in the hands-on training. So this is really something I always try to emphasize, that we're not just providing a lot of different subjects matter, okay, just like prescribing medicines to the students, to the patients, all right, and you just take it, all right, but it's more important how you integrate them. So the interdisciplinary is really, really important. So for the interest of time, I probably have 5 more minutes. I just want to get you a little bit more detail on, you would feel that, hey, I only have 4 years of study. If you tell me that I'm going to learn a lot, then can I actually go deep, right? So give you one or few examples here. Actually, in our program, okay, we actually echoing what I just mentioned about the active learning. We offered quite a number of different practical training or lab courses to the students, because we believe that, okay, in order to go deep into one particular subject matters, the only way to learn deep is to let you work on this on your own, okay, and get your hands dirty and then try to build something yourself. Then you would know, okay, what it takes, okay, to make this happen or make this fail. All right, and let the students to learn how to fail is actually very important in our program. All right, so we are not saying that, okay, we want our students to fail, but I think they need to learn by failing certain areas or certain subject matters, how to improve themselves. All right, so these are actually this experience or experiments that they are having throughout the 4 years of study, having integrated projects. This is what we call the integrated projects. Okay, this is actually the course that I'm teaching every year. Okay, 2 of the students smiling here because they know the joy and also the pain. Okay, how they have been struggling in the projects, and perhaps they will share more about this experience later on. But I'm truly believe that they learned a lot from this. And as I mentioned, there have many other laboratories that we provide to the students to experience, to learn, okay, in their practical skill sets. All right, and internship, as I mentioned, during the summer between year 3 and 4, okay, we will let the students to choose to go for internship in industry or biotech company, medtech companies in Hong Kong or even overseas. All right, or practicing in hospital. I think one of the students will actually talk about her internship experience in a hospital in one of the summers. Okay, so these are also the opportunities that we provide to the students. And there's so many more, okay? I just don't have time to talk all of them. But just to give you a snapshot that we provide the students with many outside classroom experience. We encourage the student to learn, not just sitting in the classroom doing homework, all right? So there are many other opportunities, competitions outside, and a mentorship program offered by our industrial partners. These are all possible. So when you say you can't go deep, how about you think about, you want to go deep in BME by practicing yourself, okay, in the real world situation. So this is the most important thing. This is actually one of the I would say, the signature activities or events or program, I would say, that we offer to the BME student exclusively called the Lab Shadowing Program. As I mentioned, in their year 1, okay, they may not have a very broad coverage. I mean, they're still very new to BME, okay? So this is actually a program that to let them rotate around different laboratories on campus or even in other laboratories outside campus. We also offer this lab shadowing program by the Hong Kong Youth St. John Hospital. So they can actually go to there to shadow behind the clinicians or researchers to learn more about what's real-world medical problems. Okay, so these are some of the pictures and videos that we took. All right, and a few more things, okay? Because this is a school that involves multiple faculties, all right, including engineering, dentistry, science, and medicine. So our students also enjoy, okay, the access to these facilities called InnoWing, actually established by the Faculty of Engineering, where they actually welcome, in fact, all students from different faculties going there to build their own projects. If they have their own ideas outside their curriculum, if they want to build something, okay, this innovation wing actually provide, first of all, facilities, space for the students. And second, they actually provide funding, money, all right, to the students to actually execute their idea. Okay, so we have been running this, what we call the student-initiated projects, or student interest group, for actually more than 4 or 5 years now, and more than 20, 30 groups of students across different faculties has been working in this area. All right, so towards their final year, as I mentioned, they would need to do the so-called final year projects. Depend upon their interest and their skill sets, they can have their final year projects with our professors in engineering or in medicines or actually across different faculties or even across universities. We do have final year projects that we collaborate with other professors, okay, other BME professors from other universities. Definitely involving industry partners. This is also one example that we want our students to learn, okay, what are the actual projects out there in the industry going on, and they can participate as a final year projects, okay? So, going deep by hands-on training. So this is really something that I would like to share with you, okay? One last thing, because I'm talking about BME, it's not a new program. It's been around for 20 years, actually more than 20 years now. And that's why we have been accumulating a lot of alumni, and we do have a very good and strong alumni network. And this is actually the pictures that we took half a year ago when we had this alumni day. We gather all the most of the alumni coming back and share their experience and network with our current students. And I just want to show you, okay, these 7 gentlemen in the middle panel. So they are our notable alumni because, all 7 of them right now, they are the professors in the universities in Hong Kong or overseas. Okay, and I actually would be pretty proud to say that we are the program, one of the very rare programs to generate a large number of professors, okay, in BME. Okay, and this is not something very far from your imagination, in fact. Of course, there are many other pathways. So you can think about doing further study overseas, here in Hong Kong or overseas. So these are actually some of the examples done by our alumni. And some of our students are also aspired to be the medical doctor eventually. Okay, so we do have the graduate entries. If you know, the information from the Faculty of Medicine, but that is one pathway. But there's many other pathways that our alumni have been taking, like even after they graduates and went out for jobs for some years, and they actually sort of came back, all right, to get another degree in medicine. So these are actually some of the examples. Of course, going to industry. There are actually now many more startups or biotech startup, medtech startup here in Hong Kong or across the border in this region, okay? And many of our graduates, okay, they would be working in this area as biomedical engineers. And some of them would also get into an entrepreneurship area, try to start up companies based on what they have done in their study period. This is actually the graduate entry track that I just mentioned. If any one of the students are interested in looking into this pathway, okay, this is also one of the possibilities, okay. Of course, I mean, this is competitive, all right, but this is something that we can offer to the student where upon your graduations of your BME 4 years, and you could actually go through this entry track, graduate entry track, to MBBS, so that you can have 4 more years before you graduate with the MBBS degree. For more information, this is the link. You can get to know more about that. Sorry, just one last slide. Okay, and this is actually the scheme that we have been practicing for some years already, and we are still working on. We are still going on here, and in fact, some of our BME students, okay, actually went through this scheme and now studying in Cambridge University. So this is actually the collaboration between Hong Kong U and Cambridge, focusing the subject matters in engineering and natural sciences. Okay, so when I say engineering, including BME. So the idea, so I'm not going to go through too much detail, but just 2 main points. So this is going to be targeting very top performing students, all right, because this is a very, very competitive scheme. So every year we have no more than 10 students going through this scheme. When I say 10, I'm talking about all together with natural sciences, engineering, okay, but what you are going to experience if you got to this scheme is that you study here in Hong Kong, 2 years, and followed by 3 years of study in Cambridge. Then you can actually get multiple degrees. First of all, you would get a bachelor degree provided by Hong Kong U, and you will also get a Bachelor of Arts from Cambridge, and Bachelor of Engineering from, Master of Engineering in Cambridge. So you actually can get multiple degrees, all right, through the scheme, okay, after 5 years of study. But of course, once again, this is a very competitive scheme, but I can proudly say that actually in the past 5 years, we have 3 BME students actually went through the scheme, and they are now studying in this, in Cambridge University. So I think that's pretty much what I would like to say today, and maybe I just want to go to here. I'm sorry. Okay, if you want to know more about our program, our school, so please, first of all, follow our Instagram, our social media channel, where you can find a lot of updates and exciting new information about our teachers, our professors, our students, as well as alumni. Okay, and this is the website as well. Okay, you can also take a look. So thank you so much, and now I think that this is a time for us to do some sharing, but not by me, actually by my students. So probably we have about 5-10 minutes, all right, to talk about your experience. Maybe you can come on stage. Yes, please. You can, yes. can actually all right. Okay, so now if you want to learn more about the actual current students, how they experience their student lives, I think that this is a very good occasion for you to listen to them and ask them questions as well. All right, so maybe both of you, can you introduce yourself first?
Hi, I'm Trisha. I'm in year 4, and
So my name is Sheena, and I'm also a year 4 student.
Okay, great. So now both of them are year 4, so that means they are about to graduate. So that means they had definitely a lot of experience in the program. So maybe can both of you share, so what is the most memorable experience in the past 3+ years now in BME?
I think I would definitely have to say the integrated integrated project IP. So we call it IP. So as Professor Chaz briefly introduced, we do it in year 3. So it involves kind of interdisciplinary project work. So we'll be working with our classmates to create our own prototype. For our year, we have done an SpO2 sensor, 即係夾手指一樣，你哋知道係咩嘅話，即係血氧含量嗰啲偵測器啦。咁And we have to do it from scratch. So basically the coding, the wiring. So we're making our own device from scratch, coding, wiring, design, and even down to writing a user manual and creating a final presentation for our project. That's all done by us. But we are assisted by our professors from different, disciplinaries. And for our group or my group, we have noticed kind of a gap in the market, and we have kind of designed our device based on that. And we also asked for some advice from our TAs who have helped us along the way, and that really made us kind of develop our device into what we really want. And our final design is actually a glove kind of device where you could wear it on your hand and resume your normal activities. And I think that without the help of everyone, is quite hard for us to come up with it on our own. So I think it's quite memorable because we did work very hard on it, and we stayed very late in the lab and did a lot of testing to get where we are now.
Okay, so maybe I can ask another question. So I know, Sheena, you went to hospital, right, for an internship in the last summer. So maybe can you share with our audience, what you experienced in your internship in hospital? And which hospital, if you can say that?
So I worked for the hospital authority in the last summer. So it's separate in 2 parts. One part is staying in the headquarters of hospital authority, and the second part I went to the Kowloon Central Cluster, like Queen Elizabeth Hospital and Kwong Wah Hospital. And in there, when I first thought working in hospital, I thought we would do some hands-on maintenance on medical equipment, but it turns out in hospital authority, we mainly focus on management on the medical equipment and the procurement process, like buying of the medical equipment. So it's quite different from what I've thought at first. So it is quite an interesting experience for me. I would say the most interesting experience for me. And it is really helpful because I really know what is really happening outside of the university, like what it's really like in the real industry.
Actually, talking about procurement in the hospital, in fact, whether or not you know, in Hong Kong, under HA, if you can know the names, actually some of our BME alumni, they are now actually in the procurement divisions. Some of them are actually the heads of the procurement of the hospitals. And you may ask, so just buying machines for the hospital, why do you need a BME degree? Why do you need a BME knowledge to start with, right? So it turns out the hospital over the past many years, and they found that having knowledge in engineering knowing what exactly the technical details about the technologies actually plays a very important role to decide which machines or which technologies can be used in particular hospitals based on the patient needs in that region. Okay, so it turns out it's not something you can easily hire from engineering or from business or marketing. All right, you cannot just hire them and then train them all the way from scratch. It turns out having BME background is actually very beneficial. So this is actually one example I would like to share with you that although we have been talking about a lot of very advanced frontier technologies in BME, so definitely this is one major pathway that many of our students are pursuing. But at the same time, if you're interested in going to clinical surface, or clinical areas to serve, and local hospital or many other hospitals, whether or not public, private hospitals, they actually are desperately looking for biomedical engineering graduates to join force in their divisions, to service in the different parts, okay, in the hospital. And procurement is just one of many tasks. Okay, so maybe just one last question. Since you have been studying for 3 years now, so what would be based on your own experience, okay? So, and this is all just based on their own experience, okay? Don't take it for granted, but just share, okay? So what your advice to the current students if they are interested in BME or they are still thinking whether or not BME is something they are interested in? What would be your advice?
Okay, so I think I'm not sure where everyone is now, but I've seen some some that look quite a bit older and some that look quite young. My advice, and I think I can speak for Sheena as well, I think that we both think that studying M1, M2 is quite important for, I guess, our course. It's not to say that our course doesn't provide some really good basic. I guess we have basic curriculum. We strengthen the basic curriculum in our first year, but I think that if you study M1 or M2, it really makes a difference, and it for your, I guess, future studies as well. Not only for the engineering part, but maybe further, when you're choosing your electives, you will be more confident in doing those Fourier transform and higher advanced math kind of things. So I suggest if maybe if any of you haven't selected your subjects yet, you can consider M1, M2, and if you don't worry. It's not a requirement, and the school, I guess, our school of biomedical engineering definitely gives enough support for any future students that want to join.
All right, so once again, thank you so much for both of you to share. We have about actually 5 more minutes. So I'm not sure, do we actually have some other programs after this one? Do we? Yeah. All right, anyway, so we probably have 5 minutes. So if any one of you have any questions, please speak up, and I would be more than happy to answer if I can. Yeah. Okay, thank you for asking that. That's in my backup slides. That's why you have to stay behind, right? The others just left. This is the bonus. Okay, back to here. Okay. Yes, so this is the most updated one, I believe. So we will actually also update these information in our website. Don't worry if you think that you might miss that. But yeah, so these are actually the... Oh, okay. So yeah, for IBs and GCE. So everything is actually written down here. So we don't have to, I don't have to explain too much. Oh, yeah. Yeah. Sorry.
BME. Do you consider students who apply BME as their second or third choice?
Do we, as a second choice? I think that in our experience before, we primarily look at the first choice so the students who chose us as their first choice first, because especially last year, because we received large number of applications, and due to the limited quota that we have, we basically look only in primarily and the first choice students. Yeah. Oh, right there.
Is there any interview during the admission process, or just purely based on the result?
We do have interview. So the detail of the interview, the next admission round, we will announce it very soon. But last year we did it in June. So yeah, and that is the interview for the JUPAS applicants, and for non-JUPAS, and we will actually start starting from December for non-JUPAS applicants. So we will start the interviews in December. Yeah. Oh, maybe that one. Sorry.
Thank you. I know in third year, there's a major for like cell tissue and engineering.
Yes.
From your PPT, I've seen it's more focused on the machinery side of biomed engineering. I'm curious, if you choose cell engineering, is that like, what's the difference? Is there less physics involved, like with encoding?
Yeah, very good question. So this is also the essence of BME. So we do have, quite a few of students actually interested in cell engineering or even molecular biology, synthetic biology, which is in fact also requires engineering knowledge. And we also provide courses or even some research assistant opportunities for the students to opt for, in their further year, year 3 or year 4 studies. So we do also have courses, like tissue engineering courses. And now, because we are revamping our program curriculum, we would also include more electives for our students that they're actually the courses offered by the biomedical science as well. Yeah, so including molecular biology or omics skill sets. Yes. Oh, maybe that's lady first. I think I remember she raised the hand first. And then I think next one will come to you. Yes.
Hi, nice to meet you. Thank you for the talk. And so my question is, I'm torn between pursuing a career of biomedical engineering and biochemical engineering, and I just wanted to know what are the major differences.
Okay, so biochemical engineering or biomedical engineering. So biochemical engineering, or I think that in general, people would regard biochemical engineering as chemical engineering. I know that some other sister institutions, they offer this kind of program. And chemical engineering in general, you can think of it as more generic, that you can apply these technologies into in areas not only in healthcare, maybe in environmental science, oceanic sciences as well. So these are the areas that would also involve chemical engineering. So it really depends on where you are looking at. But I also have to say that some of our biomedical engineering, actually, you remind me that one of our projects, I think some years ago, we actually worked with the microalgae, okay, that we tried to make use of actually some of the imaging approach that we use for human cells, all right, tend to detect, I'm not sure you heard of this red tide in the ocean, where you would actually have this toxic environment that you don't want to basically jeopardize the aquatic lives in sea. So the idea is very similar to like cancer screening, but not for human, but for the oceans. Can we actually detect red tide early on? All right. So that is actually the technology that you would say, yeah, require chemical engineering, but sometimes it's a mix of chemical engineering with some other skill sets. So we actually open these kind of opportunities to our students as well. I even had another project, since you brought this up. I had one student, she actually very interested in space science. So she was our BME student, And in fact, the space biology is actually an emerging science or a discipline nowadays, because here, there, people are talking about whether or not human being would be able to go to Mars in a foreseeable future. But anyway, so people are thinking about like the space biology, which also relates to healthcare, but in the space. So she actually had this project working together with faculty of science, where they have professors working in space science. So this is also all the opportunities that we open to the student to explore, actually beyond BME. Yeah, thank you. Okay, one more before we end, yes.
Right now, my chemistry is not my strong suit, and I haven't developed a strong interest for chemistry yet, and I haven't studied biology before. So I was wondering if it would be very difficult for me if I chose to study this subject, because just now from the PowerPoint, I've seen that there's a lot of biochemistry and lots of molecular science involved. So will it be a deal breaker for me if I chose to study, because I might not be, good enough or particularly interested yet?
So my simple answer is you can still choose BME, and depending upon which particular pathway you want to choose. I can pick one particular example that might need less chemistry. For example, imaging. All right, medical imaging, it's one of the areas that perhaps it really depends as well, because you can actually see that in many examples that I showed today, sooner or later you also need to have this kind of crossover with other disciplines. So, but indeed, say I myself actually working in microscopy, optical microscopy. So we build microscopes, we build imaging systems. So that requires more electrical and mechanical engineering, but it doesn't mean that it doesn't require any chemistry, because we deal with biological samples, we deal with cells, all right? So definitely there's some biochemistry involved. So this is actually something I also want to remind all the students who are still thinking whether or not BME is really something you would choose. You have to think about whether you have this mindset that you can learn something that you haven't learned before at all. But at the same time, you see this could be essential, all right? So I have been seeing a lot of students, when they first came to the BME program, yes, just like this student that, okay, I didn't have biology background much, or I don't have chemistry background. Would I succeed in this program? So he or she would actually struggle a lot, okay? But this is exactly the mindset that you shouldn't have to start with, because being in BME, you should have the mindset that you don't care to learn. You don't care to learn different things, okay? And this is exactly that I myself, many other professors, strongly believe the new generation, okay, should learn how to learn, okay? After 4 years of study, I don't know whether or not, okay, all these technologies will still be there 5 years later, all right? So the stuff that I'm going to teach you in this 5 years, to be honest, I don't know whether or not that would be applicable 10 years later. That's exactly why we want to train our students to learn how to learn by having all this practical training, and at the same time having this mentality that you don't want to narrow down your focus area too early. Yeah, just be open-minded. Maybe you are very good at chemistry. If you want to sit down and just flip a few pages of textbook, maybe you can get it. Yeah. All right, so I think that's it for today, and thank you once again so much for being here. And just one more thing, if you have time, I strongly encourage you to go to the main campus. We do have another booth there where we have students and professors stationed there and then answer your questions, as well as we have more lab tours actually in main campus. So I hope to see you there in the afternoon. Once again, thank you so much, and hope that you enjoy the rest of the day. Thank you.